let's try some more advanced algebra tile problems. Here's one. What this means is that we have a partial expression and we want to find all the possible ways you could complete this expression. So there's more than one answer probably. We're looking for a diagram with only one x squared, so let's draw that. And then remember that the x rectangles can be attached this way or this way, but that there have to be 5 of them. Now when we get the total area, we always add those two groups together and it gives us this sum. So what we're really looking for is what are all the ways that two areas could add up to 5x? So think about the sum that equals 5. What are all the ways you can get a sum of 5? Well, you could do 0 plus 5, or 1 plus 4, or 2 plus 3, and you could reverse the order of all those. So for our diagram, let's try adding x tiles to each side. Let's use one of these pairs and draw it. So let's say this pair is what I'm drawing. So I've got one x in one direction and 4 in the other. So let's go ahead and extend this, and there's all our x's. And then we finish the rectangle with 1s. This is where we fill in the blank. We use as many 1s as it takes to make this a rectangle. So it looks like we need 4. So one of our solutions is x squared plus 5x plus 4. And the dimensions for this rectangle were x plus 1 and x plus 4. So that's one solution. Let's try one of these others. So start with that x squared again. Let's try 0 plus 5. So 0 could be the tiles below the x squared, so there aren't any. And then I'll put 5 beside it. It could go the other way too. I'll just get this started. So I need 5 of these. Okay, those are all x's. Notice that I've already got a rectangle, so there's no place to put any 1 squares. And that's okay. This is one of the solutions. So the total area this time is x squared plus 5x. If we wanted to fill in that blank, we could just call it 0. And now I've shown that one. Let's try the final possibility, 2 plus 3. Okay, so we need 2 on one side of the square and 3 on the other. So I'm just going to put my 2 right here and then 3 right here. Here's 2x plus 3x, which is 5x. And now we have to complete the rectangle to see how many 1s we need. Extend all the lines that we started. And there's our little 1 blocks. Looks like we needed 6 of them. Interesting. I hope you're starting to see a pattern here. So that time we would fill in the blank with a 6. There we go. There is an interesting relationship going on with these pairs of numbers that added up to 5. Think about their products. Okay, for each one, if you took that same pair of numbers and multiplied, what would you get? 0 times 5 is 0, 1 times 4 is 4, and 2 times 3 is 6. Notice that those are the numbers we got to fill in this blank. That is not a coincidence. That's an interesting thing that happens with these. Let's look at another example. Okay, this time we're missing the middle term, so this is a little different. Let's see how many different possibilities there are that would end in a 6 and start with x squared. There's our x squared. Okay, remember that that 6 represents the area of a single space, this rectangle down here. So we need to think of 6 as a product because it's area. And what are all the ways you can get 6? You can multiply 1 times 6 or 2 times 3, and that's about it. So that rectangle is either 1 by 6 or 2 by 3. Now, since the middle term is not filled in, either is a possibility. So let's do it both ways. Looks like I've already got 2 by 3 kind of drawn, so I will finish that. There's my 2 by 3 with all my little 1 tiles. And to find out how many x's there are, I need to finish that rectangle. Extend the lines between the tiles. Don't create any new lines that weren't already there. Okay, there's our x's. Looks like we've got 5 of them, so we fill in the blank with a 5 this time. Actually, it's 5x. All right, let's see what the other solution looks like. I already did 2 and 3, so now let's do a 1 by 6 rectangle. It can be tall or it can be long. Okay, there's my little 1 tiles. There are 6 of them. Let's finish the rectangle and see how many x's there will be. All right, we've got to complete all those vertical lines. Imagine they are perfectly lined up. All right, how many x's do we have now? All right, so this time we have 6 across the top and 1 here. So that is 7 x's all together to fill in the space. And we still have plus 6 as we're supposed to have. So similarly to the previous example, Notice that there is a pattern between these factor pairs and the sums for that middle term. If we add the factor pairs together, we get 7 for that one, we get 5 for this one, and those are the middle terms that we got. Interesting. So here's the conclusion we can come to. That last number represents a rectangle with a length and a width. So you always want to break it down into factors. Let's call them n times n. The middle term is the sum of two areas. So for b, we're always looking for a sum of two numbers times x. But they're the same two numbers as the factors of c. So every time we're trying to break one of these down, the dimensions of the final rectangle are always going to be x plus one of those numbers and x plus the other number. Keep in mind that the sum of these two mystery numbers is always the coefficient of that middle term, and the product of these two numbers is always that constant term, and that will make the whole thing work. So that's the generalized strategy. I hope that helps on your homework.